All right. These ones say if the statement is an exponential form, write in an equivalent logarithmic form. If the statement is in logarithmic form, write in an exponential form. So number 12, we have 2 raised to the 5th is equal to 32. So the trick that I usually do to rewrite these to help me is if I have an exponential, you're making it a log. If you have a log, you're making an exponential. So this one, I'm given an exponential, but I need to make it a log. So I actually make an L to help me see what I'm doing. So this is log base 2 of 32 is equal to 5. Now, if you like the memorizing method that just shows you how to convert it, that's fine. I learned this method much later, and so I like this one better now that I know it rather than memorizing the formula that we started with up here. But we started with this and the problem we just had, and we went to this. The way that I do it just helps you to see exactly where things are supposed to go so you don't get confused. So then like the reverse of it, number 16, log base 5 of 5 is equal to 1. So now I have a log and I need an exponential. So I start here at the 5, I come around and I make an E. So this is 5 raised to the 1 is equal to 5. All right, 20. These ones just say to solve. So we have x is equal to log base 3 of 1 over 81. So a lot of times I will actually flip what I'm solving for to the other side and do it like this so that I can make my E. So I'm going to do this. So I have 3 raised to the x is equal to 1 over 81. So how can I rewrite 81 in terms of 3, or 1 over 81 in terms of 3?
9 squared.
Okay, 9 squared. So that's obviously going to help there. I want it in terms of 3. So then what would I do? How many times do I multiply 3 to get 81? Or, well, how many times do I multiply 3 to get 9?
2.
So 3 times 3 is 9, and 3 times 3 is 9.
So 4.
So 4. It's on the bottom, though, so I would need to rewrite this as 3 to the negative 4. Once the bases are the same, you have x is equal to negative 4. Let's see. (24) x is equal to log base 7 of the 5th root of 7. Now, what's another way that I can write a root? To like rewrite it to look different. Can raise it to some power. What power would it be?
2. 5.
Almost.
6. 7.
It's a root, so
4. 3. 2. 1. 100.
So I can rewrite this as log base 7 of 7 to the 1/5. So if we have a root, we can rewrite it as a fraction power. And then according to one of our properties that we wrote up here, log base a of a is equal to 1, okay, because that was the exponent here. Or down here, log base a of a to the x is equal to x. So, log base 7 of 7 raised to this value would just be equal to that value.
I was close. Had one of the numbers right.
Alright, let's see. 28. X is equal to 8 raised to the log base 8 of 11. So see if you can find the property and tell me what that one's equal to. Ideas?
8.
So this stuff would cancel. So you have an exponential and a log which undo each other. So that stuff goes away. So it would be equal to 11.
I knew which one it was. I knew it was happening that time.
Let's see, something like 30 log base x of 16 is equal to negative 2. So I have a log, I need it as an exponential, so I'm going to have x raised to the negative 2 is equal to 16. So thoughts on what I need to do with this one?
Do you have to like take the square root? But like, what do you do with the negative?
Well, so the negative does this, so it makes it
Fraction.
do this.
Okay.
So I technically have this. So if I take the square root of it, this side's just going to end up with the negative because it's upside down. So to basically to make this go the right way, I'm going to flip the whole thing. So I'm going to have x squared is equal to 1 over 16. So then when you take the square root of it, you would have x is equal to plus or minus 1 over 4.
That was.
All right. All right, we're going to jump down really, really far. Write each expression as a single logarithm with a coefficient of 1. Assume all variables represent positive real numbers. A is not equal to 1 and B is not equal to 1. So these are going to be the log of a product, log of a quotient, things like that. So 84, we have log base B of K plus log base B of M minus log base B of A. So our rule said that a log of a product is equal to the sum of the logs. That's also reversed. Okay, the sum of the logs is equal to the product of logs. Okay, and then the log of a quotient is equal to the difference of logs. The reverse of that is also true. So I always work left to right. So we have log base B of K plus log base B of M. So that's the sum of logs, which means I need to multiply what's inside of them. So I would have log base B of K times M minus log base B of A. Okay, the goal is to only have the word log written once. So then when we do the log of a quotient, whatever's written after the minus sign always goes on the bottom of the fraction. Okay, so this would be log base b of k times m divided by a. And that's as simplified as you can get. With something like 88, 1/2 log base a of p cubed q to the 4th minus 2/3 log base a of p to the 4th q cubed. So with this one, the first thing I would do is I would take whatever's out front and put it up top. But when you do that, you need to put it in parentheses because you have two things in here. So it would be log base a of p cubed q to the 4th, all raised to the 1/2, minus, let me do the same thing over here, log base a of p to the 4th q cubed, and all of that raised to the 2/3. I would go ahead and factor this through before you go any farther, so, or I say factor it through, you know, rewrite it. So this would be log base a of p to the 3/2 times q to the 4/2, which is 2, so times q squared, minus log base a, I'm going to do the same thing over here, of p to the 8/3 times q to the, well, 3 and 3 cancel, so q to the 2, q squared. Now you can rewrite it as 1. So it'll be log base a of the first one divided by the second one, so p to the 3/2 q squared divided by p to the 8/3 q squared.
There's a lot of 3s.
So then the q squareds can cancel, and then what do I do with the last part? The p's that are left over, so I can simplify it as far as possible.
I've got it.
How do I move things from top to bottom with exponents?
On the denominator.
Okay, ultimately, but what do I have to do first? How do I move an exponent, like from top to bottom or bottom to top?
I don't know.
To change the sign, so I'm gonna subtract, so I'm gonna have log base a of p to the 3/2 minus 8/3, then you can get your common denominator, which would be 6, so log base a of p to the 9/6 minus 16/6. So log base a of p to the -7/6, and then you can move it back to the bottom. So log base a of 1/p to the 7/6. Now, if I had really paid attention, I would have moved the 3/2 down, because that's obviously smaller than, I mean, yeah, smaller than 8/3, but I wasn't thinking about it, so. You just want it as simple as possible. All right, one more. Number 90. 5 times log base A of z plus 7 plus log base A of 2z plus 9. Alright, so walk me through it. What should I do?
Write down the problem first.
Okay, yeah, write down the problem first. That's always a good thing.
I hate when math starts adding like words. Now I feel really confused. Not really sure what's going on.
So what was the first thing that I said we needed to do in the last problem?
Distribute.
Well, what do you mean by that?
Like, don't you put it like? I don't know.
I think I know what you're trying to say.
I don't like this.
Can't be either.
We take this
Oh, gosh.
and we put it up here.
Yeah.
That's what I figured you were trying to say. Log base A of z plus 7 raised to the 5 plus log base A of 2z plus 9. So then how do I combine that? So sum of logs, and what do I
My
do?
brain isn't working right now. I don't
You
know what's
have to-
happening.
The log of the what is equal to the sum of the logs?
The log of the product.
So what does that mean I need to do?
Like, get rid of like the 5 at the top. No.
What's product mean?
Multiply.
Multiply. So we have log base A of z plus 7 to the 5th times 2z plus 9. And I'm not going to make you multiply that out, so please leave that like that.
Oh, that's it?
That's all we're going to do with it.
Okay.
Alright, I want you to do 19, 23, 25, 29, 31, 33. Wait, not 33. Hold on. That's supposed to be 83. Hold. 87 and 89.